In this video, I am going to explain unit impulse function using MATLAB. So first, we will discuss about definition of the unit impulse function, and after that, we will discuss about unit impulse function using MATLAB program. So the continuous time unit impulse function is given by del of t is equal to 1 for t is equal to 0 and del of t is equal to 0 for t not equal to 0. So according to this definition, unit impulse function exists only at time t is equal to 0 and t not equal to 0. T not equal to 0 mean t greater than 0. T greater than 0 mean t is equal to 1 to infinity and t less than 0. So minus 1 to minus infinity, the impulse function is 0. So impulse function exists only at a time t is equal to 0. This is the graphical representation of the unit impulse signal. Similarly, in discrete case, the unit impulse sequence or unit impulse function using discrete time signal is given by del of n is equal to 1 for n is equal to 0 and del of n is equal to 0 for n not equal to 0. And this is the graphical representation of unit impulse sequence. Now go to the MATLAB, open MATLAB. CLC, clear all, close all. CLC mean clear command window, clear all and close all mean so clear all the data in the command window. Previous data will be removed. So in MATLAB, comments can be used in percentage. So now here unit impulse signal and unit impulse sequence using MATLAB. So generation of unit impulse signal. First define time axis. So t is equal to minus 5 to 5 in steps of 1, minus 5 to 5 in steps of 1. So now the range of the time is minus 5 to plus 5, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. So that is the range of the time. And according to the definition of the unit impulse signal. So what is the definition of the unit impulse signal? Del of t is equal to 1 for only time t is equal to 0. So using that definition, now here I will write x is equal to t equal to 0. Equal to is the comparison operator. So for all values of time t, now here what are the all values of time t? T is equal to minus 5 to plus 5 and check it each value of time, each value of t, okay, at t is equal to 0 the condition is satisfied. So only at a time t is equal to 0 the impulse signal strength is 1 and the remaining values of t, and the remaining values of t mean t is equal to minus 5 to minus 1 and t is equal to 1 to 5 the condition is not satisfied, and the remaining values of time t the impulse signal defined at 0. So that is del of t is equal to 0 for t not equal to 0. So subplot of 2 comma 1 comma 1. So the given figure window divided into 2 rows and 1 column, and that waveform will be displayed on the first position. Plot of x-axis comma y-axis. Now here the x-axis is time and y-axis is x. So plot of t comma x. So plot is used to generation of the continuous time signal. So plot of x-axis comma y-axis, and x-axis is time t. The range of the time is -5 to +5 for each value of time t. So according to this condition, the signal exists only at a time t is equal to 0, and the remaining values of time t, the strength of the signal is 0. So now save the program and run the program. Give the file name, give any file name, .m. So MATLAB programs are saved in .m extension. Click save button. So this is the graphical representation of the unit impulse signal or unit impulse function. So this is a continuous time signal. Now here the increment value for each increment of the each value is 1. So now here I will change range of the time t is equal to -5 to 5 in steps of 0.1. So 0.1. So the increment of the each value is 0.1 -5 plus -5 plus 0.1 -5 plus 0.2, like that. So now save the program and run the program and observe the waveform. Okay. So the impulse function exists only at a time t is equal to 0. So now I will increase the line width. So the default color of the waveform is blue color. So if you want to change the color, now here I will use color. I am considering the color is C, and increase the line of the width. The syntax is line width. So line width is 2, and x-axis is time axis. X-axis is time and y-axis is amplitude. So using X label inside the single quotation or the double quotation, time t, and y-axis is amplitude. Using y label command, y label inside the quotation, amplitude x of t, and title of the given signal is unit impulse signal. Using the title function, title of inside the quotation, unit impulse signal, unit impulse function. So grid on. So grid on means the vertical lines and horizontal lines will be displayed on the graph. So now here in this graph there is no horizontal lines and vertical lines. This is a plain graph. So when you use the grid on command, so in this graph vertical lines and horizontal lines will be displayed on the screen. So now save the program and run the program. So this is a graph. Unit continuous time, unit impulse signal. X-axis is time and y-axis is amplitude, and title of the given signal is unit impulse signal. Simply unit impulse signal or continuous time unit impulse signal. And next we will discuss about generation of unit impulse sequence. Generation of unit impulse sequence, that is the discrete time unit impulse signal. So now here I am considering n is equal to -5 to 5 in steps of 1, and x is equal to n equal to 0 using comparison operator. So Using this condition, only at n is equal to 0, the condition is satisfied. At that point, the strength of the signal is 1 and the remaining values of n, the strength of the signal is 0. And subplot of 2 comma 1 comma 2. The resultant waveform will be displayed on the second portion. So the given figure window will be divided into 2 rows and 1 column, and the continuous time signal will be generated on the first portion and the discrete time signal will be generated on the second portion. So here you can indicate subplot of 2 comma 1 comma 2. And plot is used to generation of the continuous time signal. Now here we want to generate the discrete time signal. In place of plot we can use stem. Stem is used to generation of the discrete time signal. So plot stem of x-axis comma y-axis. Now where the x-axis is discrete time index n and y-axis is x. So if you want to change the color of inside the quotation G and line width is 2 and x label is the time axis, that is discrete time small n, and y label is amplitude, that is discrete time amplitude x of n, and title is unit impulse sequence. So now save the program and observe the waveform. In the first position, in the figure window, first position continuous time signal will be observed, and the second position discrete time signal will be observed. And this is continuous time unit impulse signal, and this is discrete time unit impulse signal. Impulse function exists only at a time t is equal to 0 and remaining values of n, the strength of the impulse signal is 0. And this is one way of the program, and another way of the program is another way we can type the another way I will explain discrete time and continuous time unit impulse signal. So generation of unit impulse signal. So now here initially I am considering t is equal to input of enter the value of t inside the quotation enter the value t, enter the time t value. So y1 is equal to, so t1 is equal to, so range of the time here I am considering minus t to t in steps of 1. Suppose for example I am entering time t is equal to 5. T is equal to 5 and t1 is equal to minus t to t in steps of 1 mean, that is minus 5 to plus 5 in steps of 1. So that means the range of the t1 values are t1 is equal to minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. So that are the ranges of the time t1. So that is on the x-axis. Next, according to the definition of the unit impulse signal, now here y1 is equal to inside the square brackets zeros of 1 comma t. So in my previous video I already discussed zeros function and ones function. So zeros of 1 comma 5 mean say 1 row and 5 columns only value 0 will be displayed. So that is the importance of the arrays zeros, and similarly ones of 1 comma t arrays ones. So now here zeros of 1 comma t comma ones of 1 comma t, zeros of 1 comma t. So this is the logic. Y1 is equal to zeros of 1 comma t, ones of 1 comma t, zeros of 1 comma t. Suppose for example, we have to enter t is equal to 5. So according to the definition of the unit impulse signal, the unit impulse signal exists only at a time t is equal to 0. So now here and the middle signal at n t is equal to 0, the strength of the signal is 1 and the left portion is zeros. So zeros of 1 comma t and the right portion zeros of 1 comma t. So in the middle value is ones of 1 comma t. So zeros of 1 comma t, now here ones of 1 comma 1 only center value. So one row and one column only the strength of the signal is 1. So zeros of 1 comma 5 and the left side and one row and 5 columns only 0 will be displayed on the graph and right side zeros of 1 comma 5. So one row and 5 columns only 0 value will be displayed on the screen, that is on the horizontal axis. Now using the command subplot of 2 comma 1 comma 1. So the given figure window will be divided into two rows and two rows and one column, and the current waveform will be displayed on the first position. And plot is used to generation of the continuous time signals. Plot of x-axis comma y-axis. Now where the x-axis is t1 and y-axis is y1 and the line width. Increase the width of the line. Two, and if you want to change the color, so using X label and Y label, create the X label, Y label, title, grid. So X label is time and Y label is x of t and title of the given signal is unit impulse signal grid. So now save the program and run the program. Now enter the value of time t. Now here I am entering the value of time t is 5. So this is the continuous time unit impulse signal. And similarly write the program on discrete time unit impulse signal. And n is equal to enter the value of n. N1 is equal to minus n2 n minus n2 plus n in steps of 1. So y1 is equal to zeros of 1 comma n. So ones of 1 comma 1, zeros of 1 comma n. Subplot of 2 comma 1 comma. So now here this discrete time signal will be observed on the second portion. Now here we will give 2. Subplot of 2 comma 1 comma 2. And stem is used to generation of the discrete time signal. Stem of x-axis comma y-axis. X-axis is n1 and y-axis is y1. Line width is 2. Color black color, and X label discrete time index, and Y label amplitude X of n unit impulse sequence. Title is unit impulse sequence. So now save the program and run the program. Enter the value of the time t. So value of the time t is 5. This is continuous time unit impulse signal. Next enter the value of n, 5, and this is discrete time unit impulse signal. So this is another way of the program unit impulse signal and unit impulse signal and unit impulse sequence using MATLAB program. So now here when you use the figure window, so this is the first one, first waveform, first program, figure 1. So now we are in the second program, second way. Here when you use the figure command, and another figure window will be displayed on the screen. So now save the program and run the program. Enter the value of the time t, enter the value of n, and another figure window will be displayed on the screen. Okay. Here also we can use, and this is the starting. Here we can use the figure command. Here use the figure command. Now save the program and run the program. Enter the value of the t. Time t is equal to 5. Okay, and n is equal to 5. And this is the first first program figure window, and this is second program figure window. So when you use the figure command, and another figure window will be displayed on the screen.